Law of cosine is pretty similar to law of sines, a little bit more difficult to use, but same situation. We don't have a right triangle, and we saw in the last section that law of sines doesn't always work. So in the situation it doesn't work, there's a good chance law of cosines will work. So when does law of cosines work? There's two different types of problems. One you'll see when you have two sides in the included angle. That means the angle in between the two sides are made by the two sides. So that's one situation this will work. The other situation is if you have three sides, you can find a missing angle. So if you have any three sides, which is pretty cool, if you can measure any three sides, you can find the angles between them using the law of cosines. So here it is. You can see it's a little bit longer. It's like the Pythagorean theorem, a squared equals b squared plus c squared, and then minus 2bc times cosine of a. And so realize the one that's by itself over here, a squared, its angle opposite of it, so here's where little a is, its angle opposite of it, is what's going to go inside the cosine. And then the other two sides go here, and it's also those two sides that get multiplied in that formula. So looks crazy, but you can kind of just, see that repetition there, that the a and a, there you go, and then b is there, and c is there. And you can see that b and c are going to be those two sides that are included by angle A. So if we want to find that missing side, we need to find the side BC. And I'll call that x. So using that formula, so remember it's a squared equals b squared, let's see if I can do this right from memory, plus c squared minus 2bc cosine of a. Let's see if I did that right. I think I did. You say, well, you're a math teacher, that's why. Maybe, but it's also not too bad to memorize if you just think about that a little bit, So what we're going to do is this will be remember that these are going to be the angle opposite of the side we're trying to find. So we're going to say x squared equals, it doesn't matter what b and c are, 6 squared plus 5 squared minus 2 times 6 times 5 times cosine of 74. So we just got to solve for x. So that's going to be 36 plus 25 minus 60 times cosine of 74. So that's going to equal 36 plus 25 is going to be 50 plus 11 is 61. I put 75 there for some reason. And that's what x squared equals, so we'll square root both sides. And usually put plus or minus, but we're talking about a side length here. So we're going to just have it positive. And that's going to be your answer rounded to the nearest tenth. So we got to go ahead and enter this into Desmos. And so I got 7.12. And there you go. So kind of the main thing what I highlighted that I think is you got to make sure that this side, if you call this x, that angle is the angle you'll be using. Let's take a look at the other situation when we need to find a missing angle. So remember the formula. We're going to find the measure of angle B. So let me use the formula using B. Just same formula. Notice that's the other two letters. And it's law cosine, so you're going to be using cosine. So we're just searching for B. Let's plug in our things there. So this is x, angle B there, and we want to use the side opposite. So just be careful there. So that's going to be 5 squared equals 10 squared plus 6 squared minus 2 times 10 times 6 cosine of B. So that's 136 there, minus 120 cosine of B, and that equals 25. So I'm going to subtract the 136 to the other side. To get negative 111. Then divide the negative 120. to have 111 over 120 equals cosine of b. And what do you do in this situation? In order to get b by itself, we do the inverse of cosine. Notice how I've always said when it's a missing angle is the only time we're going to use the inverse function. Here we see that here, that it's the missing angle we're looking for. That's why we're using the inverse function. So arc cosine or cosine inverse of 111 divided by 120. And let me make sure I'm in degrees. So I need to go back and double check that last one. Yeah, I did that last one wrong because I was in radians. Rookie mistake, right? So that's going to be 6.67. And then over here, we'll have 22.33. So really just getting that setup right, that's what you gotta make sure you're doing. Once you get that setup right, it's just solve for the value you're looking for. In this case was b. So we moved everything else over, did the inverse cosine once everything was moved over, inverse cosine of that, and that gave us our answer. And that's it for the angle. A little more difficult to find the angle, but still not that bad. And that's a lot of